Geometry 3-2, angles and parallel lines. So we're going to draw something very similar to what we drew in 3-1. We're going to have a chart that is parallel lines and angle pairs. And we are going to draw something over here. Let's go like this. And let's draw our graphic here first. This is line T, and this is our transversal. And this time we're going to have two lines, but these two lines are going to be parallel to one another. All right, line M, line N. Line M is parallel to line N. So this is a special kind of situation where we have a transversal going through a pair of parallel lines. And then here we have angle 1, angle 2, below 2 is 3, to the left of 3 is 4. Down here we've got 5 and then 6, underneath 6 is 7, and then we've got 8 there. So again, this is interior here, this is exterior here, just like before. But we're going to talk about some relationships here between these angle pairs. So, first off, vertical angles are congruent. This is something that we already know, but we're going to list these vertical angles just so you can see. So 1 and 3 are vertical angles. 2 and 4. 5 and 7. And 6 and 8. So those are all vertical angles. They are the ones that are right across from each other when two lines intersect. Corresponding angles postulate. Corresponding angles postulate says that corresponding angles are congruent. So angle 2 and angle 6 are corresponding angles. They're in the same place on different line, but they're in the same position. And since these are parallel lines, then 2 and 6 are congruent. 1 and 5 are congruent. 3 and 7 are congruent. And 4 and 6 are congruent. 4 and 8, sorry, not 4 and 6, 4 and 8. 4 and 8. 4 and 6 are congruent, but that's a different postulate. Corresponding angles are congruent in this situation. Now we have alternate interior angles theorem. Alternate interior angles. Theorem. Alternate interior angles. So if you remember, alternate means going across the transversal, and interior means between the two lines. So alternate interior angles, so 4 and 6, for instance, alternate interior angles are congruent. So 4 and 6 are congruent. And 3 and 5 are congruent. So alternate interior angles are congruent. So yeah, let's keep going. Consecutive interior angles theorem. Consecutive interior angles theorem. The angles are inside, in between the two lines, and they are on the same side of the transversal. So 4 and 5 are consecutive interior angles, and 3 and 6 are consecutive interior angles. And what we are saying with this theorem is angle 4 plus angle 5, these consecutive interior angles, if you were to add them together, you would get 180 degrees. So they are supplementary. Also, angle 3 and angle 6, if you add them together, they are supplementary, so they equal 180 degrees if you add them together. The last thing we're going to put in this chart here is alternate exterior angles theorem. So alternate exterior angles, so remember the exterior ones are the ones that are not between the two lines. And alternate means on the opposite side of the transversal. So 1 and 7 are alternate exterior angles, 2 and 8 are alternate exterior angles. And what this theorem says is that 1 and 7, the alternate exterior angles, are congruent. So 1 and 7 are congruent, and 2 and 8 are congruent. Angle 2 is congruent to angle 8. And that finishes the chart that we're going to draw. Let's move on to some examples. So here is our example. I'm going to have a line that goes like this, and then I'm going to have set of parallel lines that go across like that. This line is my transversal, and these two lines are parallel to one another, and they are line N and line P. Now we're going to label these angles 1, 2, 3, 4 like that, and then 8, 7, 6, 5 like that. Now, I should be able to give you just one measure, one angle measure, and you should be able to give me the measurement for all of the other angles. So measure of angle 5 is 72 degrees. So now I want measure of angle 1, measure of angle 2, measure of angle 3, measure of angle 4. I already have measure of angle 5, but I'm going to write it down there anyways. 6, measure of angle 7, and measure of angle 8. Now we're going to say what each angle measure is, and we're going to list the reason that we can say that. So measure of angle 5 is 72 degrees. That's that one right there. So let's say measure of angle, let's do measure of angle 7. That one's kind of the easiest one. That's the vertical angles theory, the one that's, theorem, postulate, I don't know. 5 and 7, vertical angles are congruent. So that means this is 72 degrees, and this is 5 to 7 is vertical angles. Theorem. Now let's go 5 and 8. Let's just do this little area right here. So 5 and 8, this is 180 degrees from here to here. So these two angles are supplementary. So they add up to 180. So if I subtract 72 from 180, then I get 108 degrees. So that means angle 8 is 108 degrees because of a supplementary theorem. Supplementary, we'll just say supplementary. Now 5 and 6, same thing. 108, supplementary. Angle 5, we already know, 72, that's given. Now, angle 5 and angle 4, these two are corresponding angles. Corresponding angles are congruent, 72 degrees, corresponding. Now 5 and 3, now this one is a little bit tricky. We don't have a theorem that goes along with this. These are not alternate interior or exterior. 3 is interior and 5 is exterior. So we don't have a theory to go along with that, but we know that 4 and 3 are supplementary, and we know that 5 and 4 are the same. So that means 5 and 3 are also supplementary, meaning that since 4 is 72 degrees, then 3 has to be the rest of the degrees to get to 180. So we've got 108, and I would say supplementary. 5 and 2, these are alternate exterior angles. 5 and 2, they're both exterior. They're on opposite sides of the transversal. They are congruent. They are alternate exterior angles. And then 5 and 1, these are consecutive exterior angles, but we don't have a consecutive exterior angles thing. I don't totally know why, but it's not included in the book. But we can use the same idea of 5 and 4 are the same, and 4 and 1 are supplementary. So 5 and 1 are supplementary as well. And that's what that looks like. So you go ahead and do one on your own. I'm going to draw another transversal, another set of parallel lines. Oops, not super parallel, parallel. And they are parallel because I draw these big dark arrows on each one. And I've got 1, 2, 3, 4, kind of going backwards from the way I usually do it. 5, 6, 7, 8. And so pay attention to that, because this is all going to be a mess if you don't pay attention to the way the angles are numbered. So for the U-try, measure of angle 8 is 53 degrees. So I want measure of angle 1, measure of angle 2, measure of angle 3, measure of angle 4, 5, 6, oops, ooh, getting messy down there. Measure of angle 7, and I already know measure of angle 8 is 53, and that's given. So I want the measure of the angle and the reason why it is that measure. Okay, so this is U-try, so that means go ahead and pause and get this filled out, and then we'll come back together and do it together in a moment. Go. Okay, welcome back. I'm going to fill in all of these numbers kind of quickly here. So 8 and 6, these are vertical angles. 1 and 3 are corresponding to those vertical angles. So 8, 7, 1, and 3 are all the same, 53. So 1 is 53 degrees, 3 is 53 degrees, 6 is 53 degrees. So 8, 6, 1, and 3. Now the rest of the angles I know are supplementary to the angles that I just wrote down here. So I know that those are 180 minus 53, which is 127. So 127, 127, 127, 127. Okay, so now I need to write the reasons. So I'm doing all of these reasons from measure of angle 8. So measure of angle 8, measure of angle 5 is supplementary. Measure of angle 6, these are vertical angles. 7 is supplementary. Now let's see, 8 and 1 are corresponding. Eight and 2, since 8 and 1 are corresponding, 8 and 2 are supplementary. 8 and 3 are alternate exterior angles. So they are congruent. Alternate exterior angles are congruent. Let's see. Angle 4, that's the only one that's left? All right, 4 and 8. So these are, I'm going to say supplementary as well because 8 and 1 are congruent, so 1 and 4 are supplementary, so 8 and 4 are also supplementary. And that is the U try there. We're going to do one last bit here, and that is, well, maybe two last bits. If we have a situation where we have a transversal and we have an angle here, angle 1, and it is a right angle, meaning it's 90 degrees. This line is parallel to this line. If measure of angle 1 equals 90 degrees, all angles are going to equal 90 degrees. So I could say alternate exterior angles are 90 degrees, supplementary angles are, this will be 90 degrees, so they're all congruent. All of these angles are congruent to one another. If one of them is 90 degrees, they all are, and that's what this is saying. Now, we're going to do an example of, we're going to get a little bit more complicated here. And this one doesn't really have to do with the 90-degree thing that we just talked about. This is just important to know. So we're going to label this one. Up on the upper left is 1, to the right is 2, and then below that is 3, and then we're going to skip down to this other vertex, 4, 5, 6, 7, 8. We're mixing up the numbers, so it's a little bit, you got to use your brain a little bit different way. So the transversal here is line Q. This line is R, this one is S, and R and S are parallel to one another. Measure of angle 4 is 2x minus 17. Measure of angle 1 is 85. Find x. And then we're going to do that one together, I think, and then I'm going to give you one to do on your own. Measure of angle 3 is 4y plus 30, and measure of angle 7 equals 7y plus 6. This is a 7 here. So we're going to do this one together. I want to know what y equals. Okay, let's do this one over here, the x values together, and then you can find the y values as a U try. So this is an example, and this is a U try example. All right, it's all part of this one. Here we go. Measure of angle 1. I said 1, but I didn't write it down. Okay, measure of angle 1 is 85 degrees. Measure of angle 4 is 2x minus 7. 1 and 4 have a special kind of relationship. They are supplementary. 1 and 7 are corresponding. They are congruent. 7 and 4 are supplementary. So 1 and 4 are supplementary. So what that means is 1 and 4, 85 plus 2 x minus 17, so angle 1 and angle 4, if I add them together, I get 180 degrees. So, because they're supplementary. So, don't just decide, oh, I've got two angles, I need to set them equal to one another. Pay attention to what those angles, the relationship is, and then decide how to make an equation that makes sense, and then you can solve for x. So I've got negative 17 and 85. That gives me what, 68 equals 180. Then I'm going to subtract 68 from both sides. 2x equals 180 minus 68 is 112. Divide both sides by 2. X equals 56. So x is 56. So now you go ahead and do this one. Decide what kind of relationship does angle 3 and angle 4 have, angle 3 and angle 7 have, and then decide what kind of an equation can I set up so that I can solve for y. Go. All right, let's see how you did. First, I need to look at angle 3 and angle 7 and see what kind of relationship they have. They are alternate interior angles, meaning that they are on the opposite side of the transversal and they are in the interior, and that means that they are equal to one another. So these two angles are equal to one another, so I'm going to set them equal to one another. I take, let's write this the right way. I take measure of angle 3, I set it equal to measure of angle 7. So now I'm going to subtract 4y from both sides. Since we're in geometry, we can do two steps kind of at one time. 6 minus 6 is 0, 4y minus 4y is 0. So now I have 30 minus 6, which is 24, equals 7y minus 4y is 3y. Divide both sides by 3, and then you get y equals 8. So hopefully you guys got that one all right. And we are going to go ahead. Oh, you know what? There's a little trick with this one. If you wanted to, notice how I set them both equal to 180. If you added them together, you could have subtracted this from 180 degrees and you get 95. Since these are supplementary, you could have taken this and set that equal to 95 and still found x to be 56. That's another way to do it. So anyway, there you go. That was 3-2. Good luck on the homework.